No single measure is universally superior. The choice between odds ratios, relative risk, risk difference, or hazard ratios depends on the research question, study design, and the nature of the data. For instance, in a cohort study where the incidence of an outcome can be directly measured, relative risk might be preferred. In a case control study examining rare diseases, odds ratios would be the go-to measure. Moreover, these measures aren't mutually exclusive. In many cases, using multiple measures can provide a more comprehensive understanding of the data. For example, combining odds ratios with risk differences can offer insights into both the relative and absolute effects of an intervention. The key takeaway is that context is king when selecting statistical measures. As data scientists, we must consider not only the mathematical properties of these measures, but also how they align with our research objectives and how they'll be interpreted by our audience. Consider a study examining the relationship between a genetic mutation and cancer risk. While an odds ratio might tell us that individuals with the mutation have 6.88 times higher odds of developing cancer. Combining this with the absolute risk increase and the population prevalence of the mutation would provide a more complete picture for public health planning. In another scenario, imagine you're analyzing customer churn in a subscription-based service. Odds ratios from a logistic regression model might help identify the factors most strongly associated with churn. However, complementing this with a survival analysis using hazard ratios could provide insights into not just whether customers churn, but when they're most likely to do so.